Hi, I'm José Morosoli, and in this presentation I'll be sharing with you our poster Pharmacogenomics and Ancestry, a study on allele frequencies across populations in commercial pharmacogenomic panels. In this work, we present results from a review on ancestry differences in pharmacogenomic variants associated with mood disorders. One of the most promising applications of genetic data in clinical practice is the potential to improve treatment planning. Pharmacogenomics is the use of an individual's genetic information to predict drug response and guide drug and dose selection to enable safer and more cost-effective treatment. Every year, over 1 million Australians will be prescribed a drug for which there is a well-established medication-gene interaction. 40% of these patients are predicted to be prescribed a drug for which they have one or more risk genetic variants that affect drug metabolism. However, an important gap in the evidence supporting the use of pharmacogenomic tests worldwide is the paucity of information about allele frequencies of key pharmacogenomic variants in non-European populations. For example, the frequency of the CYP2C19 sterallele number 17, a key genetic variant to identify low metabolizers of sertraline and citalopram, is reported to be around 80% in individuals of European ancestry, but it's an allele that is not seen in those of East Asian ancestry. While commercial PGX testing is becoming increasingly available both for clinicians and consumers, it is not clear if this technology will benefit all ancestry groups equally. In our study, our goal was to answer 4 questions. What SNPs are included in pharmacogenomic panels? How does the allele frequencies compare across ancestries? What genes show the largest differences in frequency? What gene-drug interactions are the most impacted? We conducted an online search for psychiatric PGX testing services in Australia and the US. This search identified 14 companies. When conducted, only 7 companies disclosed which RSIDs were included in their testing panels. This information was integrated with DB-SNP and pharmacogenomics databases, creating a rich dataset that combined PGX variants, allele frequency across different ancestries, reported gene-drug interactions, and level of evidence of all of them. Allele frequencies were obtained from alpha, exact, and normal reference panels for 11 different ancestry groups. The initial dataset included any genetic variant that was tested for in at least one commercial PGX panel, 22 RSIDs linked to 57 genes. Out of the original 220 genetic variants, 174 did not have a clinical annotation in pharmacogenomics database. The remaining 46 were reported to have at least one gene-drug interaction associated with mood disorders. The final dataset included 101 clinical annotations for 46 RSIDs linked to 21 genes. 36 out of these variants had at least one clinical annotation with a high level of evidence. Across reference panels, the average difference in allele frequency between European and non-European samples for the 46 genetic variants ranged between 0.008 to 0.224. Largest average differences were found between European and African samples. Variants associated with the CYP1A2, ADRA2A, and GMP3 genes showed the largest average differences between European and non-European populations. There were 159 publications that evaluated the gene-drug interaction associated with mood disorders. That meant 42 drugs. Sample sizes in these studies range between 1 to 4,000 participants, with a median of 138. In terms of biogeographic grouping, most studies were conducted in Asian populations, followed by European populations, and then by studies with unknown or non-reported biographic group. Most studies were cohort studies. Only 14 studies were reported as clinical trials, and 9 were prospective studies, that is, clinical or cohort studies. In summary, by combining publicly available datasets with a review of currently available psychiatric PGX tests, we provide another estimate of the extent to which the translation of pharmacogenomics in psychiatry might benefit different ethnic groups unequally. These results have several implications for public health and economic evaluations of these technologies for non-European groups that must be taken into consideration. Thank you for listening, and feel free to contact via email if you have any questions.